the heat will flow in this direction, like this, from inner surface to outer. Any reason for that? Because inner surface is at lower temperature. So therefore the heat will flow radially outward. Therefore I assumed a thin shell. So what is this? This is a thin shell. So what is this? This is a thick shell. So what is the question? Let me write here. Find the thermal resistance of thick shell of inner radii A and outer radii B. Okay, fine. So there's about the thing. So the T1 inner surface at higher temperature than the outer surface. Okay, the heat current will flow in this direction. Okay, what is first? The thin shell. So resistance of thin shell, dr. Anybody, can you tell me? First of all, why thin shell only? Why not any other structure? Because the elemental structure should be assumed in such a way that the surface area of that should be normal to the heat current. The thermal power is flowing normally. The heat current is flowing radially outward. So therefore, the elemental structure surface should be such that surface area should be such that it should be directed normal to the heat current. Okay, now we have like this here. So this is dr. Now what is the thickness of this? Let me take this is X. I'll take it. If you want to, okay, smaller, we'll write it. Thickness of this will be dr. So dr is equal to K. What is surface area of a shell? 4 pi r square. Okay, the limit will be dr is equal to 1 by 4 pi K. Okay, the resistance of this will be 1 by 4 pi K minus 1 by r. Limit will be A to B. B minus A, 4 pi K AB. This is thermal resistance of thick shell. Okay, very simple. You see that one. Just that elemental structure is something you should be very careful. The rest, everything you can manage. Okay, limits. Okay, from where to where the metal is present, from A to B. Solving will get it. Now, if thermal conductivity varies, the same thing. Let me put a condition. If K is a function of R, what has to be done? So first case we'll discuss. If K varies, K is not uniform. K varies radially. I think in the limits what will happen. So what we do is dr K is what? K naught R 4 pi R square. That's all. No, the changes we are going to make like this, and the limit will be A to B. Next step, let me go for limit. So this is dr 4 pi K naught. Limit will be A to B. The K can be variable also. K we took uniform. Here I brought K variable. Thermal conductivity varies radially. Okay, now the what is the mathematics? 1 by 4 pi K naught. This will become minus 1 by R square. Limit will be A to B. So what is the thermal resistance of this will be? R is equal to b square minus a square 4 pi k naught a square b square. Okay, are you getting the method? K can be variable also. Let it be. You can use this method. And also if k is k naught by r square, second case, let's see what conditions will come. So the limits will be dr equal to 1, 2 is also here will come, no? Yeah. Okay, this 8, I'll make it outside. Okay, thank you. Hmm? Okay, k naught by r square, no? Let me substitute here k naught by r square 4 pi r square. So this will get eliminated. dr is equal to 1 by 4 pi k naught. R square get cancels. So dr. Okay, the restants. Just only b minus c. Okay, fine. So these are the ways in which the questions will be there for you in exam. Huh?
Sir,
Ah,
sir, here, how we got areas 4 pi r square, sir?
surface area of a shell, surface of area of a sphere, not seen volleyball, basketball.
Okay, sir.
Huh?
Okay.
Physical world, very, very, very important. Shell, I'm saying, shell means what? Like shell, it's a spherical shell, no? It is not a disk. Please, you should have that minimum geometry in front of you. Okay. See, K can be constant or variable also. Okay, now similarly, I want temperature. Anybody? How to bring the temperature? Because this is T1, this is T2, no? I want temperature. I'll write thicker so that it will be visible for you. I want this temperature at a radial distance r. What is the procedure we should follow? Again, I should assume that this is one shell, and next again this another thick shell. The radius of the shell from A to R is one shell, then R to B is one shell. Then how the heat current will flow? Will flow like a will same heat current will flow because they are in series. What heat current flows here, the same heat current will flow here. Are you able to notice this one? What amount of heat is flowing in this region? The same amount of heat current will flow here, no? Thermal power. I'm talking about heat current, so that will be easy for you. So they are in series. So I want the temperature. So the same procedure, again the same method, the same ideas, everything. So there's a thick shell is there. I think do it in next page. The same idea is what I'm trying to. Okay, carry on the mathematics again. Just know what we derived with that. What is the requirement? Is telling what to be the temperature at a distance x. This is A, this is R, this is B. I want this T. So what I am going to assume is the same material, just I'm splitting up color so that you can start thinking. Oh, yeah. Okay, how to find out the temperature at that particular part. Okay, carry on. Find the temperature at a radial distance R. Okay, these diagrams of physics, lot of diagrams. Huh? Okay, somehow I managed it. What about heat current? The same heat current will flow here. No, I'll show it only one place. The same heat current is flowing. So how they are? They are in series. Again, what you can write? What is the resistance of the lower shell? Then the resistance of the outer shell. So what is the resistance for the inner shell? So let me take this is Rx, this is Ry. Yeah. First Rx. Any formula? Rx is equal to what is the formula? This formula. B minus A by 4 pi KAB. Very important. You should remember. If you forget this, nobody will help you. I'm telling this one. Even you learn this, take this coaching for another 10 years. If you can't remember the standard formula, the standard methods, highly impossible to get even MSET rank also. Forget about JEE mains advanced. Memory should be very good. How to get memory? Read again and again. That's the only thing, no? Okay, this will be, resistance of this will be R minus A by 4 pi K RA. What is the resistance of the other one? Ry is equal to B minus R by 4 pi K BR. Okay, let it be this one. So same current flows. So what is the current temperature difference? T1 minus Tt by Rx is equal to T minus T2 by Ry. Here T1 greater than T2. Where is T1? This is T1. Temperature of inner surface. T2 is what? Temperature at outer surface of a thick shell. This is what? This everything is a thick shell. Not circular disc with hole. Thick shell of inner radius A, outer radius A. This is air, this air, and this everything is iron. Hmm. Okay, no. So let's substitute Rx. What is Rx? R minus A by 4 pi K Ra. The same procedure. So 4 pi K R gets eliminated. So the 4 pi K R get eliminated. So A into T1 minus T by R minus A, T minus T2, B by B minus R. Solve for T as a function of R, you will get the required answer. So this so if you want, we can take 1 minus, so many calculations will come. No? 8 terms will come. So this, let me write it another form. T minus T by R by A minus 1, T minus T2 by 1 minus R by B. Okay, now you simplify. T1 minus T1 RB minus T plus TRB is equal to TRA minus T2 RA minus T plus T2. Solving for T will get the required answer. Okay, bringing all the T terms on one side. T1 minus T2 T2 is equal to okay, one T will get cancelled here, no? Okay, fine, yeah. This will be check it once. This will be. So this R also, if you want, you can take common and further you write. So this will be T is equal to T1 minus T2, T2B minus T1A. Oh, this everything is B. Huh? Check once calculation. I think I'm somewhere I had lost it. I feel T1 minus T2 okay. This is okay. Here I should bring this should be T2A it is. Yeah, fine then. T1 minus T2 R I'll take common. T2B minus T1A R by AB. This will be TR I'll take common. Solving for this, we'll get expression for T. T is equal to T1 minus T2. Very lengthy. Okay, this AB, if you want, you can eliminate that AB also. Yeah, I'll write last step. Okay, let me, this will be last step. So T1 minus T2 AB. Okay, check this. So this will be our expression, or you can write in terms of T1 also, that one. The expression for temperature at a radial distance R. Similarly, if I ask you same question, inner surface 100, outer surface at 50 degrees, what at the midpoint, what is the temperature? The same procedure just now what we studied. Okay, there's a purely mass based. You must be very good in that integration. That's all, nothing else is there. K can be variable, K can be uniform. Here we took K to be uniform. Same K it will be. Let me take another structure. These are very standard one, spherical, cylindrical one. Okay, let me go for next, a cylindrical